All right, starting out, and let me get my DQO thing open. Oh, what am I thinking? I need the white paper. All right, everybody should really take out their white paper, as we're gonna, the slides here don't encapsulate all of the details that are going on. Now, we looked at the DQO process yesterday, and we looked at the 7 stages. Within each stage or step, there are actually usually multiple functions that have to take place. And we're going to start here on page 53. Okay. And the scenario is that there's a company that is doing a composting, and basically they're trying to follow the 40 CFR Part 503 Subpart D requirements for controlling pathogens and vector attraction, and to achieve Class A status, which is basically unrestricted. Is that a fair statement?
Unrestricted use of biosolids.
Okay, good. So they need to achieve and maintain uninterrupted temperatures above 55 degrees Celsius, or about 130 Fahrenheit for 3 consecutive days. And that, as they say, will knock out all the pathogens. And so we start with step number 1, state the problem. There are really several stages here. There's a problem description, there's establishing the planning team, and there's defining the conceptual model. Okay, we've actually discussed all those, but now we're going to try and do this in a semi-real context. The problem description is basically that they need to develop a cost-effective system to monitor the composting piles so that they can meet the requirements. Okay, that's fairly straightforward. We reiterate in there some of the aspects that there's standards, there's time and temperature constraints, and the scope of the DQO process will be to develop the procedures that verify temperature data meet the regulatory requirements. Okay, and the reason we want to do this with temperature data is that the alternative is sampling. Okay, that's going to be a lot more expensive than just taking temperature measurements. So that's our problem description. We have to meet the requirements. It's all about temperature and time, because otherwise then we go to the more expensive method of laboratory analysis, or we just punt and say, sorry, it's waste. We'll pay for it to go to the landfill. Okay, so there's sort of 3 options. Make it good, or make it maybe good and sample and try and prove it that way, or just send it off as hazardous waste.